A virtual private network, VPN, functions as an overlay network utilizing network virtualization to expand a private network over a public network like the Internet, employing encryption and tunneling protocols. Within a VPN, tunneling protocols are employed to transfer network messages from one network host to another. Businesses often use host-to-network VPNs to allow remote users secure access to an office network via the Internet. Site-to-site VPNs establish connections between two networks, like an office network and a data center, enabling secure communication. Provider-provisioned VPNs segment portions of the provider's network infrastructure into virtual segments to maintain privacy between different segments. Individuals also utilize VPNs to encrypt and anonymize their network traffic, with VPN services offering access to their private networks. Client-to-site VPNs connect remote users to a central network, providing a secure and encrypted tunnel for individual users working from remote locations. On the other hand, site-to-site VPNs connect entire networks over the Internet, ensuring secure communication between separate locations. Intranet VPNs connect various parts of an organization's internal network over the Internet, similar to site-to-site VPNs. Extranet VPNs link a company's network to another organization's network to facilitate partnerships. SSL VPNs offer web browser-based access using the Secure Socket Layer protocol, while MPLS VPNs utilize multi-protocol label switching for reliable network interconnections, commonly used by communication service providers for enterprise customers. These various VPN types address different connectivity requirements by balancing factors like security, cost, and ease of deployment. A network comprises communicating computers known as hosts that exchange data through communication protocols with the help of networking hardware. Computers in a network are identified by network addresses, enabling rule-based systems like Internet Protocol to locate and identify hosts. Hosts also possess host names, which are permanent labels for the host nodes. The transmission medium supporting data exchange includes wired media like copper cables, optical fibers, and wireless radio frequency media. The arrangement of hosts and hardware within a network forms the network topology. In addition to physical transmission media, networks consist of network nodes, such as network interface controllers, repeaters, hubs, switches, routers, and modems. A network interface controller, NIC, connects a computer to the network media, with each NIC having a unique media access control, MAC, address. A repeater acts as an electronic device that cleans network signals of unnecessary noise and retransmits them at a higher power level. Ethernet repeaters with multiple ports are known as Ethernet hubs. Hubs aid in collision detection and fault isolation in a network. Bridges and switches, operating at the data link layer of the OSI model, forward frames of data based on the destination MAC address, assisting in network segmentation for improved efficiency. Routers are internetworking devices forwarding packets between networks based on addressing information. Modems, short for modulator-demodulator, connect network nodes via wired or wireless mediums. Communication within a network relies on communication protocols, a set of rules for exchanging information, often organized into protocol layers following the OSI model. Network packets are formatted units of data carried over a packet-switched network, comprising control information and user data. The Internet Protocol Suite, TCP/IP, is fundamental to modern networking, offering connectionless and connection-oriented services over an unreliable network. Virtual private networks, VPNs, enhance privacy and security in network communications through encryption methods. Split tunneling enables users to access different security domains simultaneously using various network connections. VPN classification is based on topology and technology, with configurations like host-to-network and site-to-site connections supporting different network requirements. Trusted VPNs rely on a single provider's network security, while secure VPNs enforce security measures internally or trust the underlying network for secure data transmission. Dynamic Multipoint Virtual Private Network, DMVPN, serves as a dynamic tunneling virtual private network found on various routers and operating systems. It enables the creation of a dynamic mesh VPN network without the need to statically pre-configure all possible tunnel endpoint peers. DMVPN eliminates the requirement for load on the hub to route data between spoke networks. Ethernet VPN, EVPN, carries OSI Layer 2 Ethernet traffic as a virtual private network using wide area network protocols like multi-protocol label switching, MPLS, and virtual extensible LAN. Multi-protocol label switching, MPLS, in telecommunications employs labels instead of network addresses to direct data from one node to the next. MPLS is commonly used in forwarding IP protocol data units and virtual private LAN service Ethernet traffic. MPLS, in conjunction with the Internet Protocol, IP, supports the creation of dynamic, transparent virtual networks and the ability to transport layer VPNs with overlapping address spaces. Virtual Private LAN Service, VPLS, allows Ethernet-based multipoint-to-multipoint communication over IP or MPLS networks, enabling geographically dispersed sites to share an Ethernet broadcast domain. Provider-provisioned VPNs, PPVPNs, are virtual private networks implemented by connectivity service providers on a network they manage. Virtual private networks rely on tunneling protocols such as IPsec, which uses encryption to secure IP packets inside IPsec packets. IPsec tunnels are established using the Internet Key Exchange, IKE, protocol. Another significant protocol is Transport Layer Security, TLS-SSL, which can secure individual connections or an entire network's traffic. OpenVPN, SSTP, and WireGuard are other notable VPN protocols offering secure tunneling options. Third-party applications may implement additional protocols not natively supported by operating systems, expanding the capabilities of VPN connections. Network appliances like firewalls often include VPN gateway functionality, supporting various protocols for remote access or site-to-site configurations. The realm of VPNs has witnessed a significant increase in individual usage, with projections indicating substantial market growth in the coming years.